So far, you have any doubts on the map part which we saw yesterday?
It's okay to know.
Yeah. So, what are the different type of sorting algorithms you have heard so far? Any idea? You can mention the list if you remember any.
Quick sort, bubble sort,
Sorry, can you come again? First one.
quick sort, quick,
Quick sort, okay.
bubble sort,
Bubble sort, okay. Any other things have you heard so far? Merge sort.
merge sort,
There's something called insertion sort and heap sort. Also selection sort. I think these are the sorts mostly used in Java and other things. These are things. You remember any other sorts from your side? Okay. So first, let's see the merge sort. So what type of strategy do we follow in merge sort? Let me go to the pane. So what type of strategy do we use in merge sort? Any idea?
divide and conquer.
Yeah, exactly. So we actually divide and then conquer the final result sets of how we want to sort our results. So let's take an example. 19, 13, 11, 5, 23, 12. Okay. So what happens, like this list, whatever data you get, right, is should that be a sorted one? It can be an unsorted one in case of merge sort.
And then it should be sorted, right?
So basically the elements order will not be changed. So whatever order or whatever data set you receive, it will remain in the same pattern. So it is not like you need to sort it out first and then go and achieve the result set, right? It is not that way. It is always with the data, however you have in your thing. So what is the strategy we have is we actually break this one into a multiple segments. So how are we going to break? It is n by 2 policy. So since we have 6 elements, it is going to be break into 3 and 3. If suppose if you have an odd elements based on that 4 3 or 3 4, however you want, you can actually sort them out. So if I need to sort this, first I'll sort this 19 13 part into two things. So 19, let me first go to the left section, 19 13 and 11. So what happens in 19 30 11? That again will be further sorted into two sections, n by 2 again. So it will be 1.5. So I'll take the whole as 19 and 13 as one section and 11 as my another section. So again, when it is coming with 19, 13, what happens here? The sorting performs. So when I'm trying to divide this again, what I'll do, I do the sorting operation. So on these two elements, I'll do the sorting. So what happens in the final end, I'll get the result as 13 and 19. And then I go ahead with the 11. Now I need to merge again this. So far the divide has happened. And again on division, I'm performing the sorting part. So after this, when I compare again the three elements, again my sorting is changed because 11 is the smallest element. So I need to perform sorting here. So what happens now? 11 comes as first and 13 and 19 will be interchanged. So this entire set will be interchanged to the next position of my 11 and the lower one will come to the previous position. So this is the way the ordering happens on my left side of this particular element. If I see on the right element 5, 23, 12, can someone say like how this gets sorted out?
It will divide.
Yeah, so
5
5
and
is the
23.
first and 23 would be the first section. And the second section will have only 12. Now again, when I further sort this 5 and 23, are they already in sorted order or they are in unsorted order? 5 and 23.
Already in sorted order.
So they're already in sorted order. So when they wanted to do one more divide method, there will not be changes here. So it will always remain 5, 23 and 12 only on the next stage also. So now when I complete, when I merge, when I'm trying to conquer, like basically merge these three, what happens? The sorting is not in a proper way. So what happens? The 12 might come in between these two. So my sorting will be in terms of so here this happens with 5, then 12 comes in, then 23 moves out. So how this actually happening? Like how is my element is knowing that this 12 has to be inserted between 5 and 23? Because the 5 and 23 will again be divided, and after that each element will be taken care. And after once you achieve this 5, 12, 23, this 11, 39, then again this combination will be again taken care here. So here 5, 12, 23. So now these two are sorted, but if you see again, my data is not sorted completely. So the 5 has to go again onto my left and 12 has to go onto my left. 13 and 19 has to move on. So how this logic works? So let me open this one. So to implement the merge sort, what is the complexity you see in this particular diagram? Like what are we doing every time? Divide and conquer, what are we doing it? Are we repeating the same operation again and again? Or the complexity is similar or is it different?
We're repeating the.
Yeah. So let's say, let me write a method. It will be public void. Okay. So the three elements which you need to merge, right? Every time you're comparing with the previous one. So how are we doing that? What is the basic strategy here? So you need the array of elements, right? So you need an array of elements. And for every element, you're going to compare the thing like middle element, left element, and the right element. So every time you're going to compare your next, immediate, and then the rightmost. So you need three positions data: integer left, integer middle, and then integer right. Okay. So you need these three inputs, only then you will be able to go ahead with your merge sort. Okay, so how do you identify your lowest element as well as the highest element? Basically, the lowest element is left and the highest element will be high. Let's say in your data set. So my lowest, like starting with 19 and ending with 12, right? So how can I find the lowest element in the entire array, and the highest element in the entire array? Let's take the same array again. 19, 13, 11. Okay, let me have my int array equal to 19, 13, 11, 5, 23, 12, 5, 23. This is my array. So now I'm going to do the sort part. So to do the sort thing, I'm going to call a merge sort method. And from that merge sort, I'm going to pass all these elements every time when I do the merge operation. So let me have a thing called sort by merge. So now what all things I need as part of my sort? The same thing, but only thing is I will not know the middle position. I will not know the middle position, which I'm going to calculate and then divide it later for the divide and conquer. So what this particular position will have is the same int array, and my left position so here I'll pass my array object. And what is my left and what is my right? So the left position is like basically the first element, right? So it always starts with the index position of array starts with Janaki and Kirba.
0.
Yeah. So the left position will always be 0. What would be the right extreme? How can I make the right extreme?
Array minus 1.
So the left minus 1, right? So
Length of array.
here that will minus 1. So this would be the my extreme right position. So the extreme left position starts with 0 index and the right is the overall length minus 1. So I'm just taking this one. So now within this, I'm going to use this internal method of merge and then call the things. But first I need to identify my middle position. So whether my array is having the exact middle like n by 2 or not. So I'm going to identify my middle position here. Okay. How will I identify my middle position? Let me default it with 0. So how will I identify the middle position? How will I identify? So what is the usual formula we identify for middle position is n by 2, right? So or the n by 2 is nothing but totally the total number of elements, or you can also go with the values which you have with you, like left and right divided by 2. You can either go with overall length by 2 or left plus right by 2. It's your wish. You can go with anything. So you already have your left and right. So we just divide by 2. You can go with anything. Either you can just go with the entire right divided by 2 also, because that will give you the entire index position. So now this would be your calculation for your middle element. So what is the actual criteria you're going to do? Only if my initial left position is minimum than my right, I can go ahead. Otherwise, the formula might not work. If my left position is with 10 and my right position is 5, will that work here? This will end up with a failure. So what we do is we keep a constraint check, like every time my left. So far, we are good on the public, sorry, mergeSort so far.
I'm facing some network issue. I'm not able to see a screen.
Oh, okay.
Is it the same with Janaki?
Oh, yes, Kirpa. Even I'm not able to see.
You're able to see my screen now?
You can see it now,
yes.
but your voice is breaking. Okay.
Just a minute.
Oh.
So is it audible? Is it better now?
It's audible, but your voice is breaking, and sometimes you are losing.
In between, it is getting stopped.
Oh, okay. Let me know if that happens again. I can switch the network. Yeah. So, like, are we good till now? So we have taken a sample array, and we are going to calculate the middle element with the position of left as well as the right position. And we are making a check like every time my left index should be lower than the right one. So only then I'm okay to calculate my middle element. So after this, what are we going to do in the merge sort? So what did we do here is we are segregating the left array and then doing the sorting, segregating the right array, that is divided part again, and then doing the sorting. And finally, we are doing the sorting for the entire left and right array merged together, right? So the 3 sections we are going to do here. So the first thing will be your left subarray, like a left part of the array sorting, and then a right part of the array sorting, and then finally when you merge together, you're going to do one more sorting on top of it. So how are we going to call this? So for right now, we are going to use this merge method here, and we are going to pass our parameters here. Same thing on the right sorting. Okay, and finally the third will be the together sort, where I'm also again called the merge method. So now what would be the attributes? So this is right now going to do for my left part. So what are the things do I need to pass for my attributes? What are the things I need to call? So the merge is accepting array, left, middle, and then right element, right? So when I'm calling the merge sort, what all things do I need to take care of? Okay, let's forget about this right now. So you just tell me when I'm calling the merge method, I have my array already handy. I have my left element already. I have my middle element. I have my right element. So this should be fine for me to start to go ahead. So what am I doing in the merge part?
Merge, you're just comparing.
Yeah. So basically we are going to compare the elements. So now in your array, so let's say now I'm taking this left position 19, 13, 11. So in 19, 13, 11 to compare, I need a prefix value of lower and suffix lower element and the higher element to do a comparison every time with 19. So let's say I'm taking 19 as my lower. So I'll compare the 19 with 13 and I come to know that 19 is no more lower, 13 is lower element. And again, I'll compare 13 with 11 and then I get to know 11 is my lower element, not 13 anymore. So my lower element will be replaced every time. So first I need to identify the lower element and the higher element from my array. So that would be the first step. So how will I identify my lower element and right element? So let's do the lower calculation first. So what will happen? Basically from your middle position, you're going to minus your left position and then you're going to add 1. So let's say my left position right now is this one, 19. The middle position, okay, let me give the array. So what would be the left here? 0. Middle would be like 0 plus the length is. Can someone say me what would be the value for middle here?
3.
So 3. So now what happens here when I'm doing the calculation? 3 minus 0 plus 1, which is nothing but 4. My lower element position would be the 4th position. Is it right or is it wrong?
So this one is wrong, right?
Yeah. So why is it wrong? Because your array dot length, right? The length is 1, 2, 3, 4, 5, 6 minus 1. So it is 5 actually. So the right element is 5. So 0 plus 5 by 2, which is 2.5. So we take 3 as max to the maximum element, but it's actually 2.5. So my middle element would end up with 3. So when I come here, 3, did I write correctly the image question? Yeah. So let's also take the higher part, then we'll compare both. So what would be the higher way? How can I calculate the higher position? Right minus middle will work. Are you with me so far?
Yeah, but these terms are a bit confusing. Left, right, and low, right? So
Okay, so basically the left and right is to your entire array, the way you sort your order, right? It goes from your left to right. So that is the reason I took the left and right. And why did I took low and high is like to compare the data in it. So lower element and the higher element. Basically to identify the sorting data part, we need the lowest element or the higher, what to say. As in an ascending order, you need the lowest value the first, right? To compare and do it. So that is the reason I'm taking it as lowest and highest.
But how we are using that middle minus left plus 1 for finding the lower? Just a trial or trial
I'm
and
just going
error?
with a trial.
Okay, okay.
It's not a fixed one. Let's fix it based on our logic. Okay.
Okay.
So I'm just going with right minus middle will give me the higher end. Left middle minus left will be the lower end. But this plus 1 also you can leave it right now. You can just have middle minus left. Okay. So the middle would be the intermediate value 3, 0 minus 3. And then this side it would be like right 5 minus 3. So that would be the range. So now what happens? These are nothing but the values, and these values you have to fetch it from your array. And then only we are going to do the iteration. So we need 2 for loops, for example, and for iterating the 2 positions, we need 2 for loops. Why do we need 2 for loops? Let me tell you now. So if you see right now, let me take the position in I equal to 0, I less than, I'm iterating from a left position, basically the lower element side, and I plus plus, okay, the lower element. Same thing, I need another loop, which I'm going to iterate from j equal to 0, j is lesser than highest value, and j plus plus. Okay, so now I need 2 arrays which can hold the final sorted values from to consider this as my data is getting merged or updated, whatever. I needed 2 arrays to keep the updated values. So I'm keeping like low array. It is not accepting lower array equal to new int, which accepts the size of my low. And I'll take this as higher element, which accepts the position of my high value. So every time when I'm doing this iteration, so let's say the lower value is 4 this time. So in the lower array, the element will hold, this lower array will hold values of 4 things. So because new int of 4, so you will have the values from 0, 1, 2, and 3. Okay. And in case of higher element, the right is like 5, 5 minus middle is 3. So 5 minus 3 is 2. So this will hold data set of 3, 0, 1, and 2. So when I'm coming into this, when the lowest element is 4 in my, it's not 4, 3 in my case. So I'll do 3 iterations. So for I equal to 0, 0 is less than 3. It goes into the loop. Now what happens? I need to take the element from my array. So I need this array value here. And I'm going to fetch it value from it. And I'm going to assign to my lower array part. So lower of I. Okay. So how am I going to get the left position? Basically, you're identifying, you're iterating from your left place. So in your array, right now you're in this part, 19, 13, and 11. So array of lower element of 0 is having 19, and I'm assigning that to my lower array. So in this part, what logic do I need to take care of in the array? Which element do I need to consider? So because my position starts with 0, in the left, the position starts with 0. So do I need to give left plus I, or I can just give left? Did you get the logic? If I give array of left, it will be array of 0. If I give plus 1, every time the next element I also will be taking care, because my lowest element, the left element, is also 0, and the I is also starting with 0. So what happens? The first iteration, let me take here. So the first iteration, my I is 0. Okay. So when it goes internally, I'll compare 0 with the lower element of 3. So which is 0 is less than 3. Condition is true. So it goes in. And then now what I'm doing is I'm adding the data into my lower array. Basically, I'm sorting and I'm maintaining an array to give the final results. So when I'm taking this lower array, the array of left is nothing but my initial value, which is 0. And then the I value, which is I'm going to do the performance of iteration for a number of lower things, which is 0 plus 0 is 0. So basically array of 0, which is nothing but the element 19. Okay. So what happens now? The lower of 0, lower or array will hold a value of 19 so far. Okay. Now again this goes into the next loop. I is incremented by 1. Now my lower of 1 position is actually I'm trying to update here. So where the array will be, left is still 0. There is no change in left, but the I is get updated with 1. So my value is array of 1. So my array of 1 is 13. So I'm splitting that and keeping it in the second position. Now again, when the I becomes iterated, the I is plus plus 1, it becomes 2. Now it is still 0. So 0 of plus 2. So my array of value will be 11. So I'm fetching and keep it in the lower part. So this loop gets ended up here. So same thing happens into the higher loop on the higher node. So what would be the criteria there for the higher of I value?
You used middle minus right something, right? So from there we will get that
So
I
let's
value.
say I'm going to add the elements to my higher array. Okay. So yeah, how would I get the data from my array here?
Here of J,
Sorry,
here of J,
array of J. Okay.
I mean higher of J, let's say. Not let's say line of 39, higher of J,
Okay. So
array of
now in this J element, I'm going to fetch. So J is 0, which is basically iterated. But
mid plus
mid plus
J will work, right?
mid plus 0 or mid plus 1?
Mid
Because
plus
right
J.
now my middle is 2, right? So if I say 2, 0, 1, 2 is still 11. Do I need to take 2 plus 1 or do I need so mid plus 1 or do I need to take only 2?
Mid plus 1.
Yeah. So I need to fetch the value of middle
Yes.
plus 1 plus my J position. Okay, J will always be the iterated value. So now let's go here. Now J is equal to 0. Now 0 is again, sorry, not 0. J 0. 0 is lesser than, what is the high value now? The high value is 2, right? So now go here and when you're updating in your higher array the first time, so what will be the value? So when you go here, it will be middle. Middle element is 2. 2 plus 1 is 3. J is 0. So 3 plus 0. So 3. So 0, 1, 2, 3, which is 5. So I get updated here with 5. Okay. Now again, the J gets incremented with 1. So 1 plus 1, 2, and middle is already 2. So 4. So 0, 1, 2, 3, 4, which is 23. I'll go and get it and add it into my this. Now again, J gets incremented by 1. So which is 2. 2 is less than 2. Will that satisfy my condition or not?
Then 2
Sorry?
then 2 will fail.
That will fail. So is it right now I'm having the sufficient data because I'm leaving one element, right? In that case,
Yes, equal
what
to
is the right value? So there is some change on my right position. The right value is not right for me because I'm missing one element here.
so 2 is you can add plus 1 directly, right minus middle plus 1.
Right,
931.
middle plus 1. Okay.
Or we can modify the for loop condition, right? I less, sorry, J less
Yeah,
than.
you can either modify the loop or you can modify the higher position. So now my high is like again with right minus, so which is again 3. So now here when it comes to the position of higher, the higher would be like with 3. So my condition satisfies. I will be able to fetch the data of 12. Okay. So this is done. So far this is done. So let's just print and see what is the data we have in our lower array. I'm not writing a loop to avoid the constraint. I'm just printing it to just check our data. Not writing a loop. So what is the issue? We got array index out of bound exception. So let's say let's remove this and identify what we are getting. So we are again getting a bound exception in case of lower element. We didn't go for higher itself. In lower itself, we are getting a thing. Where are we failing it? Can we check that? So let's put +1 here. And I'll just print the mid and out elements. So if you see, my middle element is 2, left element is 0, right element is 5. So the total size is 6. So 6 minus 1, 5, right is correct. And the left is 0 is correct. And when we are doing the left plus right by 0, it is not taking the maximum. So it is 2.5, but it is taking the lower value, which is 2. Okay. So now when we are calculating the lowest position and the highest position, earlier we added +1 here to fetch the highest one, where it went with index out of bound exception. But instead of adding the +1 here, if we add it over here, the lower elements will not get that index out of bound exception. Are we clear till this part or any confusions?
Yeah, okay. Okay.
Only thing is the way we calculated in terms of middle element is getting changed. It is not taking the maximum part, it is taking the lower part. So 19, 13 and 11 went into the lower, 5, 23, 12 has come to the second array part. So till those, any questions on this iteration so far?
Okay.
Okay, right? Okay. So now after getting the lower element and the higher element, we actually need to sort the further part. So basically the 19, 13 and 11 has to be sorted again. And then 5, 23, 20, 12 has to be sorted again. So after doing segregating to the main component, we are going to do it again in iteration. So let's go with the while loop. Okay, how are we going to do? So basically what you're going to do is every time the element which you receive is going to be compared with the lowest element, and every time the element which you received on the j has to be compared with the highest element. Basically I less than low and j less than high has to be considered, and then we are going to add them into the final array list, array of k or array of m, whatever it is, where you're going to assign it. So basically now what we are going to do here is we are going to introduce a variable equal to with the left element. So far the left element which you received was 0. So it is starting with int n equal to 0. So now you already have the I and j already defined here, but it is local. So let me take it outside. Okay. So now here I'm going to use my I initialized position again. So once my I loop is over, what I'm going to do now is I'm going to compare my lowest and the highest element. So basically I less than low, and together I'm going to compare the next element, which is j less than high. So if both are satisfying, only then I'll be going into my while loop, else I won't. So there might be cases where few elements will not satisfy in both criteria, right? So where you need to have a separate criteria for my lowest part and a separate criteria for my highest part. So I need another 2 loops. Where my I is greater, so lesser than lower element, and my j is lesser than high element. Okay, so basically every time when you compare these elements together, we need to compare and then make a sorted one. And separately also you need to sort this array. So that is the reason we have taken the lowest array first, highest array while loop, and together, basically together after sorting, you need to do one kind of thing. So basically 3 while loops we are using. That is the reason. Any confusion still this on the merge part?
Can you repeat the need for 3 while loops?
Yeah. So what is the first thing you do in your array? So first you're going to take your left subarray 19, 13, 11, do the sorting and you get an final data. 5, 23, 12, you do the sorting and you get a final data. After that, you're going to compare the entire sorted array and then you make it a proper sorted one because they are not together as sorted again at the end. So you need one more thing where you're going to perform one more sorting on top of it. So there are 3 kind of looping you need to take care of. On dividing you need to do, on merging also you need to do. So there are 2 things, right? On dividing you have left array and right array. On merging you'll have a single array. So basically the left array, right array, and on merging together. So any criteria can match in any cases. Are we good till this? Why we need 3 loops?
Yeah, okay.
So now again my I is not initialized because it is locally initialized. So I will initialize it again, I equal to 0 and j equal to 0. My initialization is done because it was locally done. So it will be only for my for loops. Okay. Now when I go to the, let's go to the left subarray. What will I do? So I'll go for the lower part. I need to take care of lower array. So I'll be fetching it from my lower array. Okay. So I'll be fetching my I values. So basically all the I values on the iteration, I'll fetch it from a lower array. Okay. And after fetching it, I'm going to assign it to which element, which is the final element I'm trying to fetch all my data on n element. So I'll add all these details into my array of n. Okay. And after adding this, I need to increment my n as well as my I to perform my one more I loop. Sorry, while loop. So I need to increment my I value as well as I need to increment the array value where I need to add my extra data set. Are we good till now here? So basically the low value is something which is already defined in our case, which is nothing but mid minus left, 2 minus 0 plus 1, which is 3. Okay. So my lower value, I'm going with the left one. So lower value is, so when I go I is 0, 0 is less than 3, condition is true. So when I go array of 0, so array of left position is initially initiated with 0. So array of 0 will hold a value of lower of I. So the lower of I is having the value of 19. So my data for array of 0 would be 19. And then I'm incrementing my I and incrementing my n. So what happens now? The I will be equal to 1 and my n will be equal to 1. So again, I'll come loop. So right now 1 is less than 3. The condition is true. And I'll go back and I have to increment my value for n where n is right now 1. So array of 1 will be by lower of 1. So lower of 1 is 13. Okay, I'll assign my array of this with the respective position. Again, I go and increment I plus plus. So I will become 2 and n will become 2. And I'll go here an array of 2, which is equal to lower of 2. So the lower of 2 is 11. So I have